Now we will explain the physiological change during exercise. Okay, if you are doing exercise, what will happen? So first of all, organ and tissue work hard. You have to understand that organ and tissue work hard during exercise. For example, musculocutaneous system do its job. Other is the cardiovascular and respiratory system make a quick physiological adjustment. For example, if you are exercise, it is not normal rest state. In normal rest state, the heart rate and the respiratory and the cardiovascular system are working. It is not just like normal mechanism. Okay, it become during it now become now you are exercising, so now you have different adjustment needed, so meet the skeletal system demand. For example, if you are in for a skeletal muscle contract harder and fast. For example, you are exercising, so your skeletal muscle need more energy, more nutrient, more oxygen and more nutrient. So the cardiovascular system and respiratory system make adjustment. So first of all, endocrine system secrete cortisol and adrenaline. Cortisol and adrenaline. And what it do? It increase the intracellular process. Just simple. It increase the intracellular process. First of all, this is your muscle. This is your complete muscle. Okay. And muscle. Now if you this is the fascia of your muscle. Now there are muscle fiber present in it, and these are multinucleated. Okay, sarcoplasm, myofibril. This is the sarcomere. This is sarcomere. Now this is thin actin and thick myosin. Thin actin and thin myosin are present here. Now they are slide over each other. Actually, they slide over each other and form a contraction and relaxation process. So the next thing is the slide over each other. So when they slide over each other, they make a contraction. Okay, now I have told you, for example, this is your form a cross bridge. This is your ATP. For example, this is the head of myosin. Okay, when the ATP combine here, it form ADP and energy, and they form a cross bridge by using ATP. Use ATP, myosin head bind. Okay, by ATPase myofibril sarcomere. This is myofibril number of. So you have to remember, using ATP, what will do? It form a cross bridge and use that ATP. Now another thing is you have to understand the sarcomere. Sarcomere is the smallest unit of the muscle fiber. Okay, they during contraction they contract and relax. Okay, number of it also number of backward process, number of log. Now first of all we will tell here number of book or hook process. For example, substrate phosphorylation. Another is the anaerobic glycolysis. For example, there are myofibril. So number of myofibril that bind that contract depend on the things. First thing on depend is the on the substrate phosphorylation. Another is the anaerobic respiration. So substrate phosphor when ATP is used, how the ATP is regenerated. So there is a creatinine phosphate. Okay, creatinine phosphate have a creatinine phosphokinase. They give creatinine and phosphate, and these phosphate use to regenerate ATP. Okay, another is the anaerobic respiration. Glucose convert into pyruvate and they form 2 pyruvate lactic acid after 1 minute. Lactic now here the lactic acid formation is increased. So during exercise this process is being happen. So after 1 minute the lactic acid is increases. When lactic acid increase, they go to the bloodstream. Okay, and the blood pH become decreased. When the blood pH is become decreased, what will happen? They are in the peripheral there are peripheral chemoreceptor in the aortic body and carotid body. They response to this signal and give information to the brainstem, and in brainstem there is a respiratory center. They activate the respiratory center for increasing respiration and deep breathing and cause hyperventilation. Okay, this is the simplest mechanism. Another is the second is the pulmonary vasodilation. For example, another the thing happen is the pulmonary vasodilation. If the pulmonary vasodilation occur, blood flow to the pulmonary and bronchi increases, so tissue perfusion is increased. When tissue perfusion, we will explain it in the respiration that what is tissue perfusion. So if tissue perfusion is increased, the efficiency of gas exchange also increase. Okay, now So we have already explained it. Now another thing is that when blood pH is decreased, it give in response to a carotid body. Okay, and cardiac center. It give response to a cardiac center, and cardiac center actually increase the sympathetic flow and decrease the parasympathetic. And sympathetic from the adrenal gland, they secrete the epinephrine. Okay, epinephrine is a adrenergic receptor. Have adrenergic receptor on the heart. They goes to the heart, and on the adrenergic receptor, what do they actually increase the heart rate and contractility. So this is actually the mechanism that is happening. Another is the adrenaline. I have also in the beginning of this video I tell you that adrenaline is secreted. Okay, we are I will show you here. Here cortisol and adrenal is increased. What they do? So now come here and go to the adrenal. Adrenaline is actually do vasoconstriction in the smooth muscle and vasodilation in the skeletal muscle. You have to understand this, that adrenaline vasoconstriction in the smooth muscle. So toward the smooth muscle, for example stomach, etc., the blood flow is decreased, and much of blood flow go toward the skeleton because adrenaline cause vasodilation in the skeleton. So increase muscle activity, due to which the muscle activity is so much increases. Okay, force blood metabolite, and lactic acid is increases, hydrogen ion is increases, partial pressure of oxygen is increased, and partial pressure of carbon dioxide is increased. Okay, so local blood vessel relax, and current counter effect the sympathetic vasoconstriction. Now you have to understand that what will happening here. Actually adrenaline do increase the blood flow toward the skeletal muscle. When blood flow is decreased, there are muscular activity is increased. When muscular activity is increased, lactic acid, hydrogen ion and carbon dioxide is increased, and oxygen concentration is decreased. Now these are actually the local metabolite. Okay, these are the actually local metabolite. And we also tell that the cardiac center have sympathetic activity. It increase the sympathetic activity, and sympathetic activity cause vasoconstriction. But in the muscle, why do it not cause vasoconstriction? Because here are metabolite are present: lactic acid, hydrogen, oxygen, carbon dioxide. They are local metabolite. They actually vasodilator. So they counter effect the sympathetic vasoconstriction, and here in the muscle the vasodilation is occurred. Okay, now active and functional hyperemia is the increase in the activity, okay, of specific organ. For example, systemic vasoconstriction plus muscular dilation. Actually system is vasoconstrict but muscle are dilated. Blood flow for the muscle is increased and blood flow for other organ is decreased. Okay, as a result ATP generate aerobically instead of anaerobically. When more blood is go toward the skeleton muscle, so more oxygen is go toward the skeleton, and as a result the if the oxygen is present, there will be aerobic respiration occur. Now what how aerobic respiration? This is the cell membrane. Okay, and in this cell membrane there are electron transport chain is present. First of all, pyruvate convert to into acetyl CoA, there goes toward Krebs cycle, and from the Krebs cycle the NADP and FAD is produced, and this NADP and FAD goes through the electron, give hydrogen to the electron transport chain, and these hydrogen move out from the cell membrane, and this is actually the between the two cell membrane of the mitochondria, space between two cell membrane. Okay, intercellular membrane space. Now these hydrogen move to the inside by the cell through ATPase, and these ATPase create ATP. So a large of ATP is created. So oxidative phosphorylation occur. Okay, final step is cellular respiration. So 32 ATP is produced here. Now this is actually I am talking about the exercise, that what things are modification occur during exercise. So aerobic respiration during exercise for 1 minute. If you are aerobic respiration greater than 1 minute, if you do exercise, aerobic respiration will happen. Metabolism increase to point where oxygen consumed and CO2 produced. Cellular metabolite is equal to O2 breathing in and CO2 breathing out. For example, O2 you breathe in and CO2 breathe out. these become increase. Okay, so mean arterial pressure of O2 and mean arterial pressure of CO2 become stable. In venous blood during exercise, in venous blood what will happen? Partial pressure of oxygen is so much decrease and partial pressure of carbon dioxide is so much increase. Okay, this is about aerobic respiration. If you exercise more than 1 minute, okay, these all modification will happen during exercise. Now for example, if you do long term exercise, what modification will happen? So blood glucose level, for example, for long time the blood glucose level become decreases. When the blood glucose level become decreased, what will happen? So actually in long term exercise, the blood glucose level become decreased, okay, because it is used. Now what will do? Glycogen is present in the muscle and in the liver, all glycogen. So epinephrine is released from the kidney, okay. And what epinephrine do? Epinephrine do actually glyc glycogenolysis. Glycogen lysis, actually it convert glycogen into glucose. One thing is it. Another is it also do lipolysis. Lipolysis means lipid and fat convert into free fatty acid. Okay, long chain of fatty acid convert into break into fatty acid, short chain of fatty acid, and H2O2. H2O2. This is hydrogen peroxide is produced, and when hydrogen peroxide is produced, peroxidase, actually there are peroxidase present, and that peroxidase enzyme convert H2O2 peroxidase. You have to remember this is very important. I will show you. Okay, for example, long chain of fatty acid convert into short short chain of fatty acid plus H2O2. H2O2, okay, and this H2O2 convert into H2O plus O2. And another thing you have to remember that these processes occur by H2O2 is convert into H2O by what will happen? Actually there are peroxidase enzyme, there are peroxisome, and peroxisome or peroxidase enzyme convert this into H2O2. So you have to remember, if long chain of fatty acid and they create the H2O2, and H2O2 convert into H2O2 convert into H2O plus O2 by peroxidase by peroxisome I peroxidase enzyme. Okay, now another thing, so short fat or short chain of fatty acid become, and fatty acid, when short chain fatty acid created, they go toward Krebs cycle, etc., acetyl CoO, and form and give energy. Okay, another is glycogen. Glycogen convert into glucose. So muscles will always have enough glucose to break. Now as a result, glucose amount become increase in the muscle to use for the energy. Okay, now you have to remember about the beta oxidation. Beta oxidation is fatty acid convert into acetyl CoA, and these acetyl CoA go toward the Krebs cycle and oxidative phosphorylation for ATP generation. For example, there are free fatty acid convert go into bloodstream and into the muscle. They have beta oxidation. Okay, what is beta oxidation? Beta oxidation, or beta oxidation is actually for example, this is beta oxidation. Actually fatty acid convert into acetyl CoA, and acetyl CoA go to the Krebs cycle and use for ATP generation. Okay, so this is called beta oxidation. Okay, so now we will tell about the regular exercise. If you do regular exercise, it is very helpful. Body adopt itself. Okay, increase efficiency and capacity during exercise. If you are exercising again and regularly, so your body become adopt and your efficiency and capacity become decrease. Okay, heart muscle hypertrophy will also occur. Your heart muscle hypertrophy of your heart muscle increase, your heart become hypertrophy, and this is physiological condition. And normally if you, and after when the hypertrophy occur, so the heart, the myocardial oxygen and heart can easily work, do a lot of work without anything. While another thing you have to remember, while heart rate increases, okay, for example rest, you are now at rest, okay, and your heart rate is for example 70 beat per minute, okay, and you after you have do 1 month exercise, or you have do exercise regularly, so after that when you are at rest, your heartbeat will be for example 65 beat per minute. Your heartbeat become increase. Why? Because your heart have hypertrophic muscle. Now your heart at one beat they at one beat, at a single beat, they the stroke volume become decreased. At a single beat they can they can go, for example, from the ventricle to the aorta, a lot of blood move. Okay, ejection fraction is increases, and that's why your heart for the normal blood flow, for example at rest you need for example mm, you need a 4 liter 4 liter blood to pump out at per minute. Okay, so it is actually, if you are not having exercise, your heart is not hypertrophy, so this 4 liter is released from the heart by 70 beat. But if you do exercise and your heart become hypertrophy, become so much bodybuilding. Okay, so what we'll do after that, less by less work, by less beats, the 4 liter blood is delivered to your body. Okay, this is simple mechanism. Now after that we will explain ECG, electrocardiography. Okay, for the PDF and for these notes you have, if you want to download these notes, I will give you a link, and also you use our app, we will upload our app, our website, everything. Okay, thanks for watching.